Okay, chapter 7 starts out with divisibility patterns and prime factorization. So 2 parts to this. Divisibility patterns. So what are some things that we see happening all the time with division? Okay, a number is divisible by another number if the top number is divisible by the second number. In other words, the one on the bottom. Okay, notice that's a division problem there because every fraction is a division problem. So this guy right here is a division problem. You understand that, right?
Yeah.
So if this was a number, so 7 and 14, you would have 7 divided by 14, right? Or hopefully today we're going to do like 14 divided by 7. So 14 divided by 7 gives me 2. Okay, so it's divisible if when you do that, it leaves no remainder. So we say numbers are divisible by each other when they leave no remainder. So 14 divided by 7 would be
2.
divisible, right? Because it leaves no remainder. It's a whole number answer. So 6 divided by 1 is 6. It's divisible. 6 divided by 2?
3.
3. It's divisible. 6 divided by 3?
2.
2. It's divisible.
No.
6 divided by 4?
2. No. 1.2.
1 point.
1.8.
Who knows?
1.6. Wait, 1.6.
You guys all have a calculator, right?
1.4.
Quick, do it.
But it's not a whole number.
How many times does 4 fit into 6? It fits in there 1 full time with
And then 0.2.
2 left over. 1.5. 1.5.
I literally guessed that.
No, you didn't. You said 1.2.
I said 1.2 and then I said 1.5 and you said
6 divided by 5?
calculator.
1.2.
1.2. Guess that one.
6 divided by 6?
1.
1. So, the only 2 that aren't divisible are those 6 divided by 4 and 6 divided by 5. Yes, we can divide them, but we get a decimal answer, so we don't call them divisible.
Not like a remainder.
Yep. Okay. So no remainders when we divide, which makes life, I think, a little easier when we divide right now. A prime number is a number that is only divisible. So in other words, what we just said, when you divide, it comes out to a whole number, no remainders. Divisible by 1, the number 1, and itself. So some prime numbers: 7, 13,
12, 11, 10,
19 I heard.
17.
11 I heard, right? There's lots of them out there. Okay? 21's no. 21 is divisible by 7 and 3.
7.
Yep.
Oh, so this is just where you can only divide it by 1?
Yep. You can only divide by 1 and itself. So the only factors, the only numbers that fit inside of it are 1 and itself. A composite number is a whole number, which means no decimals, with more than 2 factors. Because prime numbers do have 2 factors, because 1 and itself, that would be 2 factors. So any other number besides your prime numbers, so like 4 or 6 or 9 or 8 or 20. That is not an exhaustive list. There's lots of them, okay? Those are just examples. Finding some factors. Do you remember what a factor is first?
Yeah. Wait, what?
A factor?
It's like finding a number that works with both.
So we have a factor times a factor equals a product. So a number times another number equals a product. That product being the number we're starting with. So like 96 here would be our product, or 138 is a product. So what numbers times each other equal 96? There's an easy one. 1 times 96.
Oh, I remember these.
Multiply them by each other. 1 times 96 gives you
96.
96.
2 and
2. How'd you know 2 was 1?
48. It's an even number.
Because 96 is an even number. 2 and 48. Three is 1.
32.
And 32.
So I got rid of
4 is 1. I might run out of room in my middle. 24.
88. 22.
6. And I'm going to run out of room. 16. I'm going to squeeze them in here. 8 and 12.
Is that all?
Okay? 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, 96. Adam says, is that all? How do I know? What do you notice about as you get towards the middle?
They get closer.
The numbers get closer together. So I could try 9. But 9 times 10 gives me 90, so I know 9 doesn't work.
Then do 9.
So now I've already used,
11.
and 9 times 11 is 96. Well, if 9 and 11 don't, or 99, sorry.
Oh, okay.
If 9 and 11 don't work, what's the only one that's left?
12.
10, only the middle number, right? So we've run out of numbers to try. So when we find factors, little side note here, you want to check for divisibility until the numbers meet in the middle. So 8 and 12 there are pretty close together. You only have 9, 10, and 11 left. So if it's none of those, then you're done. We've done every other number. So I like starting at the bottom end. So 138. We'll do that one down. I'll do that one down a little bit lower. Just move this guy down here. 138. So obviously 1 and 138 work. Does 2 work?
Yeah.
How do we know?
So even
It's an even number.
69. Is it?
Should be.
3 works. That's
3.
46.
46?
Yes.
Okay.
Well, you're using calculator. Yes, I am. You thought they were just doing that all in their head. Yeah. 4 doesn't work.
4 doesn't work. Does 5 work?
Yeah. No.
How do we know 5 doesn't work?
Because it goes by 5, 10, 15, 20, 25, 30, 40.
Because it doesn't end in a 0 or a 5.
6 works.
6 works? 6 times what?
23. 7 doesn't work.
What's interesting about 6 is because 2 and 3 work, 6 works.
Yeah, I didn't get that. I'm not already. 2 times 6, 8.
So we're getting close together. 7.
7.
Said 7 doesn't work?
8 probably does.
8. Doesn't work. 9. 10.
Yeah. No.
Doesn't end in a 0, right?
Yeah.
11.
Nope.
We're getting pretty close to 23, right? Why don't you try 11 times 11 a minute?
It's like 130. It's 121.
Okay, what about 11 times 2? Or even times 12, sorry. 11 times 12.
131. 232. 132.
Okay, 11 times 13.
143.
So we're above our number, right? So if 7, 8, 9, 10 didn't work, and we're at 11. 11 doesn't work. We've done 11 times 13. What's the only number that's left? So does 12 times 12 work? No, so we're done. We don't have to try any more numbers. We don't have to try 14, 15, 16, 17, 18, 19, 20, 22. Because we've already found out that 11 and 13 don't work.
Why does that matter?
Because they're close together. So now we don't have to try any numbers bigger than 13.
But why though?
Yeah, like why?
So 11 times 13 equals what? What was it? 143?
Are you talking about what the answer is? 'Cause it's
11 times 13 is 143. Correct?
Oh, because it's too high. So
It's too high. So we have to be smaller than 13.
Okay.
And we've tried 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So the only number we have left to try now is 12. 12 times 12 is 144. And that one doesn't work, so we're done. So these are all our factors right here. Okay, so you try them until you get close together.
Don't we do 2 and 3 though?
We already did 2 and 3. 2 times 69. 3 times 46. Okay? All right. So to help you out, because yes, you could plug them all into your calculator and try to figure it out. But why try some if it's not worth it and you can just figure it out without pushing any buttons on your calculator? Okay? So for the number 2, what do you think the rule is for 2? If 2 is divisible. If it's even. So if the number's even. Let's do the 5. What has to be true for 5 to be divisible?
Last is you 5 and
Yep,
0.
is a 5 or a 0. Let's do 10. If it ends with a 0. Those ones are pretty quick. Those ones you shouldn't really have to think much about. You can look at the number and say yes or no for 2, 5, and 10. 3, if the sum of its digits is divisible by 3.
Can we keep this out on a test?
For example, 729. Add up those numbers. 7 plus 2 plus 9. What is 7 plus 2 plus 9 equal? Equals 18. Is 18 divisible by 3?
6.
So yes, so then you would say that 729 is divisible by 3. Because 18 is. That's the 3 trick.
You have to figure it out.
I'm only asking, is it divisible, yes or no, at this point. Okay. 4. Actually, let's do 9, because 9 is very similar to 3. If the sum of its digits is divisible by 9, and I just use the division sign there, okay? Instead of writing the word out. So again, if we have our example of 729, we have 7 plus 2 plus 9, we get 18. So is 18 divisible by 9?
Yeah.
Yeah, so that means 729 is divisible by 9. Okay?
How crazy is that?
Now, the other thing with 9s, if 3 doesn't work, 9 won't work. Okay? If 9 works, 3 will work. So if you've already figured out one of those, you'll be able to tell the other one maybe. Number 4, the 4s. If the number in the last 2 digits is divisible by 4, then the number is. So what are the last 2 digits of 812?
1, 2.
So you're just looking at 12. Is 12 divisible by 4?
Yeah.
So then 812 is divisible by 4. This one is very similar to the 8 rule. So the 4 is the last 2 digits. The 8 is the last 3 digits. If the last 3 digits are divisible by 8.
What if there's only 2 digits?
Then hopefully you know your 8 facts.
Okay.
Okay? Or you're just looking at the last 2 digits. Okay? 6. This is another easy one. If the number is even and divisible by 3. So in other words, 2 and 3 work. Because 2 fits into every even number. So 2 and 3. Then our number is divisible by 6. So those are some tricks that are helpful. So let's try a couple examples here. 7, there's not really a great rule, so good luck. There actually is a rule, but it's really kind of weird, and it's not worth trying to memorize, because I goof it up when I do it. I mean, I could probably, if I did it more, I could figure it out, but I'd rather do long division than use the 7 rule, to be honest.
Do the 7 rule. What is it?
Off the top of my head, I'd have to look it up, because I don't remember it. Okay, so what numbers fit into 5,385 evenly? Does 2 fit in there?
5.
So 2 is a no. What about 3? What's the trick? Add them up. Don't use your calculator.
What? I'm confused.
5 plus 3 plus 8 plus 5.
30. 21. 1.
So
Yes.
21 divided by 3, does that work?
Yeah.
So 3 is a yes. 4, what was my rule for 4?
If the number in the last 2 digits is divisible by 4.
The last 2 digits, so 85. No. 5,
Yes.
yes. 6, should be easy.
No.
No, because 2 doesn't work, right? 7, we're not going to worry about. 8, the last 3 digits.
No. What do you mean if 2 doesn't work? No.
So for 6, if the number 2 doesn't work, then 6 won't work.
9.
9, we already added the digits up. We got 21. 21 divided by 9?
Yes.
Nope.
Oh.
And 10?
No.
Why not 10, Adam?
Because there's no 0.
Because it doesn't end in 0.
I thought you said if 3 is. I thought you said if 3 it works, 9 works.
No. If 9 works, 3 works.
Oh.
3 has to work for 9 to work. Okay, so if 3 is a no, 9's a no. If 3 is a yes, you still have to check 9. If 9's a yes, you can just say yes to 3. Okay. All right, let's do another one. Gavin, 2, yes or no?
Yes.
Why?
Because it ends in 2.
Because it ends in 2. It's an even number. 3. Elise.
No.
Why not?
I think that was a guess.
Okay, what are you supposed to do for 3?
Yes.
Yes, because 6 plus 2 plus 1 is a 9. 4. 62.
No. Yes. Yes, no, maybe so.
Okay, how I break that up is 62. Does 4 fit into 40?
Yeah.
Okay, how many are left to get to 62?
12. 22.
22. Does 4 fit into 22?
Yes. No.
No, so it's not going to be 4. 5.
No.
6.
No. Yes. Yes.
7. We're not going to do 7. 8.
No. Wait. No. Yes.
But do you just
no.
divide this on your calculator?
So this one I would quickly just do 162 divided by 8. Doesn't fit here if it's 2 times here. With 2 here, doesn't fit here. I'm going to have a decimal.
No. I kind of forgot how to do division.
Okay? So 8's a no. 9. Yes, because you add them up, you get to 9. 10.
No.
No. There will be questions on your assignment that say list the numbers, what numbers from 2 to 10 that are factors of these numbers. And you don't have to write 2, no, 3, yes. You could just write, for example, 4, you would just write 3, 5, and that's all you'd write. For example, 5, you'd write 2, 3, 6, and 9. 8's probably just a quick long division problem sometimes. Okay? The other way I think about it is 162 is 80 plus 82, right? 8 fits into 80 evenly, but it doesn't fit into 82 evenly, so it's not going to fit into 162. So I'm breaking the numbers up to make them easier to think about. Let's stop there. Okay. Prime factorization is something that you did last year, I know. So it uses what we call a factor tree to break up a composite, which is a number that's not prime, a composite number into prime factors. Okay? So if we look at the number 126, what's two factors of 126 other than 1 in itself? 2, because it's even. So 2 times, I'll just give this one 63. Okay. 2, is that a prime number?
Yes.
Yeah, so we should circle that one. So I always circle my prime number so I know that's the end of that branch of the tree. 63. It's divisible by what?
3.
It's divisible by 3. Okay. So 3 and...
Is that right?
Not 17. Not 17. 3 and 31.
Have you close?
What?
And 31 is a prime.
Not 31, I'm sorry. 21.
Yes.
You were closer.
Thank you, Adam, for correcting me. 21. What is that? That's still not prime. So 3 and 7.
Both of those.
And both those are prime. So we're not quite done yet. We should always write it as a multiplication problem at the end, because if you took 2 times 3 times 3 times 7, you would get 126. That's what this is telling us. So we would write this as 2 times 3 times 3 times 7. This is the okay way to write things. The best way to write it would be 2 times 3 to the second power, because there's 2 3s. Remember in the power thing?
Yeah.
Times 7. This is best.
We have to do that?
Okay. It doesn't matter to me. What I would ask that you do, and I think maybe require that you do, is you write them the smallest numbers starting on the left. As they get bigger, notice 2 is smaller than 3. 3 is smaller than 7. I didn't write 7 times 3 times 2 times 3. Put them in chronological or numerical order. I guess it is not chronological as you go. Okay?
Yeah, go order in English.
Yeah. All right. So let's do another one here.
Understand English.
2.
What fits in there?
2
10.
10 or 2? What do you want to do? 10s or 2s?
Let's do big numbers.
Want to do big numbers? We can do big numbers. Let's do 10.
105.
105 and 2. So we got a big number and a small number. All right. So notice it doesn't matter whether I wrote my 105 on the left or right. The 2 is still the prime number. 105 is not prime though.
5 and 10. Let's do 2.
5 and 21.
And
2 doesn't work with 105.
3 and 7. I realized.
And 21,
3 and 7.
3 and 7. So this one doesn't have any repeats. So this one's just going to be a 2 times 3 times 5 times 7. So always end it with that multiplication problem. I encourage you / require you to write them in numerical order. But I also will ask that you, when you do your factor trees, that you circle the prime numbers. Okay? Try to be neat with these as you do these. It'll make life easier for you.